Hi everyone. Welcome to my channel. In today's video, we'll dive into the world of mental health conversations and how data can help improve them. We'll go through the entire process from data preparation to deploying an intent prediction model. Let's get started.
Chatbot for mental health conversations. Introduction. Building chatbots to provide emotional support for anxiety and depression is a growing focus in AI. A crucial component is a well-structured dataset for training models to respond empathetically. This dataset is a comprehensive collection of mental health conversations, including basic exchanges, FAQs, therapy discussions, and general advice for anxiety and depression. It aims to train a chatbot to offer empathetic and supportive responses. Each message in the dataset is categorized by intents representing the purpose behind a user's message, like sadness intents are paired with example messages patterns and appropriate responses. This structure helps the model learn to identify user intents and generate relevant, compassionate replies. Using this dataset, researchers and developers can train chatbots to better support individuals coping with anxiety and depression, offering emotional guidance and helpful insights.
First, we need to prepare our data. This involves collecting chat data, cleaning it to remove any unnecessary information, and structuring it for analysis. Clean data is crucial for accurate results. We import the JSON module. Then, we open the intents JSON file from the specified path and load its contents. We create a data frame from the intents data. Now we can see the output, which includes the tags, patterns, and responses. Next, we perform exploratory data analysis or EDA. This step helps us understand the data better by visualizing trends and patterns. We'll look at word frequencies, common phrases, and sentiment analysis to get insights into the conversations. We start by importing Plotly's Graph Objects module. Next, we calculate the count of each intent by using the value counts method on the tag column of our data frame. We then create a bar plot using Plotly, setting the x-axis to the intent names and the y-axis to their respective counts. We update the layout to include a title and axis labels. Finally, we display the plot showing the distribution of intents. We have the distribution of intents. This bar chart shows how often each intent appears in our dataset. As you can see, the greeting intent is the most common, appearing 12 times. Following that, we have intents like goodbye, help, and understand, which also appear frequently. Moving down the chart, we see that intents like fact 5, fact 9, and fact 13 are less common. This gives us a clear picture of which intents are most and least frequent in our data. In this step, we analyze the patterns and responses within the chats. This involves identifying common themes, triggers for certain responses, and understanding the flow of conversation. This analysis is key to building an effective prediction model. We create new columns in our data frame to count the number of patterns and responses for each entry. We use the apply method with a lambda function to calculate these counts. Next, we calculate the average pattern and response counts for each intent by grouping the data frame by the tag column. We then create a bar plot using Plotly, adding traces for the average pattern count and the average response count. Finally, we update the layout to include a title and axis labels, and display the plot showing the pattern and response analysis. Next, let's look at the pattern and response analysis. This plot shows the average count of patterns and responses for each intent. The blue bars represent the average pattern count, while the red bars represent the average response count. We can see that some intents like fact 3 and fact 27 have high pattern counts but low response counts. This discrepancy indicates that these intents appear often in patterns, but don't receive as many responses. On the other hand, intents like suicide and user advice show a more balanced ratio between patterns and responses. Now, we move on to building the intent prediction model. We'll use machine learning algorithms to predict the intent behind each message in the chat. This helps in understanding what the user needs and providing appropriate responses. Now, we move on to building the intent prediction model. We'll use machine learning algorithms to predict the intent behind each message in the chat. This helps in understanding what the user needs and providing appropriate responses. We begin by importing the necessary libraries for our machine learning model and visualizations. First, we split our dataset into training and testing sets. The patterns column is our feature set, and the tag column is our target variable. We use an 80-20 split for training and testing, respectively. Next, we vectorize the text data using the TF-IDF method to convert the patterns into numerical form. We then train a support vector machine classifier on the training data. After training, we predict the intents for the testing set and evaluate the model's performance using a classification report. We convert the report's float values into dictionaries for better handling. We extract the evaluation metrics, specifically precision, recall, and F1 score, for each intent. Finally, we visualize the model's performance using a plotly bar plot, where each metric is displayed for comparison. The plot is titled Intent Prediction Model Performance and includes labels for the intents and scores. Here's a bar chart showing how well our model performs across different intents using precision, recall, and F1 score. Blue bars indicate precision, red bars show recall, and green bars represent the F1 score. High scores for intents like greeting, goodbye, and fact 6 show our model's strength. Lower scores for intents like anxious and casual highlight areas needing improvement. The weighted average bars give an overall view of the model's balanced performance. Once our model is built and tested, it's time to deploy it. Deployment involves integrating the model into a chat system where it can analyze real-time conversations and provide insights or responses based on the predicted intent. We'll demonstrate the deployment of our prediction model. We have a trained SVM model named model and a vectorizer named vectorizer. First, we define a function to predict intents based on user input. This function vectorizes the user input and predicts the intent using the trained model. Next, we define a function to generate responses based on the predicted intents. The function includes logic to respond appropriately depending on whether the intent is a greeting, farewell, question, or something else. For example usage, we set up a loop to continuously get user input. For each input, we predict the intent and generate a corresponding response, then print the chatbot's response.
Here are some example outputs from our chatbot. Chatbot, hello. How can I assist you today? Chatbot, hello. How can I assist you today? Chatbot, I'm here to help. Please let me know how I can assist you.
You can find all the code from my notebook using the link below. To wrap up, we've walked through the process of preparing data, performing EDA, analyzing patterns, building an intent prediction model, and deploying it. This approach can significantly improve the quality of mental health conversations and provide better support to those in need. Thank you for watching, and don't forget to like, share, and subscribe for more data-driven insights.